Now, when you are determining whether or not a function is linear or quadratic, sometimes you're going to come across equations, tables, and graphs that are neither linear nor quadratic. So when that happens, you're looking for, remember that in an equation, a linear function will have degree 1, so your highest exponent is a 1, and a quadratic function will have degree 2. So anytime you see an equation that has an exponent other than a 1 or a 2, or it's got a trigonometric function in it, it's neither linear nor quadratic. So for instance, this function here, I noticed that it has an exponent of 5, which tells me it's not linear or quadratic. Same here, again, that exponent is not a 1 or a 2, so not linear, not quadratic. And then h of x, I can see has a tangent in it, and so that tells me that it's trigonometric and not linear or quadratic. So when I'm looking at an equation, I'm trying to decide whether or not my function is linear or quadratic. I'm thinking about the exponent. And if that exponent is anything other than a 1 or a 2, or it has trigonometry in it, then it's not linear or quadratic. So I would say that the function is neither linear nor quadratic because the degree is not 1 or 2. When I look at the graph, remember that linear functions have a graph that is a line, and quadratic functions will graph a parabola. So when I look at graphs of functions or equations that are not lines or parabolas, then I can identify them as being neither linear nor quadratic. So I would say the function, the graph is neither linear nor quadratic because the graph is not a line or a parabola. Remember, it's got to be one or the other. If it's a line, it's linear. If it's a parabola, it's quadratic. And if it's not a line or a parabola, then it's neither linear nor quadratic. And then finally with the table, we're also going to look at the differences. Remember, if your first differences are the same, it's linear. If they're constant. If your second differences are constant, then it's quadratic. And if neither, right, the first or the second differences are constant, then it's neither linear nor quadratic. So we'll take a look at the first differences. -8 minus -7 is equal to -1. -7 minus -5 is -2. -5 minus -1 is -4. -1 minus -7 is -8. And 7 minus 23 is -16. So the first differences are not the same, which tells us that it's not linear, but we should also check the second differences to see perhaps if it's quadratic. So I'll do the differences. I'll take the differences one more time. -1 minus -2 is equal to 1. -2 minus -4 equals 2. -4 minus -8 is 4. And -8 minus -16 is 8. So first differences, not constant. Second differences, also not constant, which means that this function is neither linear nor quadratic. So what I'll say is that this table is neither linear nor quadratic because neither the first or second differences are constant. And that's how we decide. If they're not linear or quadratic, that's a conversation for another day about what they might be, but we're looking for the equation. Remember, we're looking for degree 1 or 2. Degree 1 is linear, degree 2 is quadratic. If it's neither of those, it's neither type of equation. Same thing for graphs. If it's a line, you have a linear function. A parabola is a quadratic function. If it's neither a line or a parabola, then it's not linear or quadratic. And then with that table, make sure to take the differences once. If they're not the same, do it one more time, and then you don't have to do the differences after that. Either the second differences are the same and it's quadratic, or they're not, and then you don't have a linear or a quadratic function.